Hello dear friends, welcome. In this lecture we want to calculate the internal force of a beam which acting or influence trapezoid loading as you see in the screen. This is a beam that length is about 10 meter, 4 meter and 6 meter in this part acting triangular load and in this part acting triangular loading in this part a rectangular loading. So I want to calculate the internal force reactions and draw the diagrams of it. As you know, we have a different method for finding and calculation of internal force. And this lecture I want to explain the section method and calculate the internal force by a section method. First of all, I want to find and calculate the reaction of this beam. As you know, this definite beam, it has three unknown or three reaction, Cy and Ay and Ax, and also we have three static equation, summation of fx along to x axis equal to 0, summation of equation along to y axis equal to 0, and summation of moment in every point equal to 0. So it's definite. First of all, I want to calculate the reaction of this beam. First, I want to take a moment at optional point, but it is better or good that you take a moment in a specific point that the most of the unknown or a reaction cross from that point. So in this example is the best point that I take the moment. So I write summation of MA equal to 0, but direction is optional. You can the direction choose clockwise or anti-clockwise. It's a contraction among or in front of yourself. So I accept and counterclockwise positive. In this part, AY and AX cross from the A point. They don't have arm, and it will be 0. So in this part, the menu or negative, because it is it is clockwise. 1 of 2, it's the formula of calculation the area of triangular, multiple by 4 because 4 is the base, and multiple by 6 because it's the height of this triangular, and product or multiple by 2/3 of the base. It is as you know in physics that the centroid of a triangular from the vertex is equal to 2/3 of the base. Mino or negative, instead of negative of this part, also acting clockwise, 6 product or multiple by 6. It is the length of this girder, and it's the height of and the load acting on that beam, and product or multiple by the arm of this loading. As you know, the centroid of this the rectangular is in the middle. We have 4 plus half of this arm, 6 of 2, and the reaction of Cy acting counterclockwise, so it is positive plus Cy multiple 10 equal to 0. So cy is equal to, we contracting this part, rubber fit 1 2 2 4 and 1 3 2 3 6, and it's remain 2 multiple 2 multiple 2 multiple 4, and also this positive because we carried from the over of equation. 6 product 6 plus 4 and 6 divided to 3 plus 4 equal to 7, and we calculate of them divide by 10 equal to 28.4 kilonewton. So the cy is calculated. Now we want to calculate the fy. It is the up direction. I accept positive. Ay minus of 1 2 of the area of the triangular, 4 product or multiple the 6, and minus of, because it is in the downward direction, 6 per multiple 6 plus cy equal to 0. After operation and contraction on, we carry them to the over equation. Ay is equal to 2 per multiple 6 plus 6 multiple 6, and minus cy, we change or put the price of cy in this place, as so equal to 19.6. and the reaction of ay also calculated. Now we want to calculate the reaction of ax. Summation of ax equal to 0. We don't have our external load, so ax is equal to 0. The reaction of this beam calculated. Now we want to calculate the internal force. As you know, that every part of a section has 3 internal load, shear, moment, and normal force. And also we divided this beam to 2 parts because the shape of the load acting different. This part is rectangular and this part is triangular. So first of all, we calculate the first section. This part, we take a section, and the length of this section is equal to x. X is upper than 0 and lower than equal to 4 meters, because that has 4 meters. Okay, dear friends, now I want to calculate the internal force of this part, V1 and N1 and M1. This point we called O1. We first of all calculate the height of this triangular. We have a proportion between this according to the similarity of the triangulars. This triangular is similar to this triangular. We take a section from this point, and W of x equal to h of b, according to the similarity of triangulars. This triangular and the before the triangular is similar, so we can take this equation and we put the price of them. H is equal to 6 and b is equal to 4. This is h and this is 4. So we find and after abbreviation, W is equal to 3 of 2 product by x, and this equation find it's actually a function according to the change according to the x. After that, we use the static equation, some summation of fy along to y direction equal to 0. So we can write 19 plus 19.6 minus 1 of 2 w product x or multiplied by x minus of v1 equal to 0. So v1 carry over the equation, and it's equal to 19 plus 0.6, and we put the price of w in this part. After the operation, we find this equation. So we can write the diagram of shear by giving to write the price for x. When we give the x 0 in this equation, v1 equal to 19.6, this point can find. And when we give the x equal to 4, the price of this equation or v1 equal to 7.6. This part can calculate. Because it is quadratic, we draw the diagram curve, and it is the shear force diagram according to the kilonewton. And also we take moment at a point of O1. In this point, we take a moment. The direction of movement is optional. Generally accept the counterclockwise positive and clockwise negative. So we can read minus 19.6 multiplied by x, because it is clockwise, and in this loop act counterclockwise, we can read positive plus 1 2 multiplied by x multiplied by w, and also a plus m1 equal to 0. So we can carry this part to the over side of this equation, and sign change negative to positive and positive to negative. And also we put the price of w from this equation after the operation, and simplifies to make simple, we obtain or receive this equation. It's the moment equation of this part. We can draw the diagram of a moment by giving a favorite price for x. When we give 0 to x, this point obtain it's 0, and when we give for x, this point obtain the price is to 2.4. And also summation of fx along to x direction equal to 0. So we don't have external force in this part. In 1 is equal to 0. The second beam calculated. Okay, now we calculation the internal force of the second beam or second section. This part that load is acting as rectangular shape, this part. So we can take a section from a side that we want, but it's important that you choose those side that's easier or simple for you. So you can calculate this section from the left hand also, but it's a little difficult. I choose from the right hand. In this part we take section, and the length of this section is also equal to x change to vary from 0 to 6. It is bigger or equal to 0 and lower or equal to 6. So we use the three static equation. Summation of Fy equal to 0, the upper direction we accept positive, V2 minus 6 multiplied by x plus 28.4 equal to 0. We change this part to the over of equation. V2 is equal to 6 x minus 28.4. This is the equation of shear in this part. When we give a favorite price for x, we can obtain the price of v. When we give 0, v is equal to 28 point. For this point become a receiver obtained. And when we give 6 for x, v equal to become 7.6. This shape obtained. It's the shear force of diagram in the second section. And also we take a moment in O1. So the direction was also optional. I take it counterclockwise positive and clockwise negative. Summation of M2 is equal to 0. So we can write minus M2, and this part the moment act clockwise, and also minus 6 the rectangular area multiplied by x multiplied by arm. The half of this length is the arm of this load, plus it is counterclockwise plus 28.4 multiplied by x equal to 0. M2 is equal, okay, we carry moment to M2 the other side of equation, and after contraction M2 is equal to 28.4x minus after observation or contraction 3x quadratic or x square. When we give a favorite price for x in this part, so we obtain this shape. When we give 0, this point become receiver obtain 0. When we give x equal to 6, and this point obtain 62.4. But one thing you should remember, the point the shear is 0, moment became the maximum or take maximum price. So for finding of this part of moment price, we take the shear and we make equal to 0. So we can find the price of x after we need this equation equal to 0 become equal to 0. The x become 4.73, and we take this price and put to this equation. After the calculation, we obtained the price of maximum moment 67.21 kilonewton meter. It is also the second or beam or section. Now we can join two diagram to or combine to one diagram. After that, this general diagram obtained that it is belong to the trapezoid loading, and it is we want to check summation of Fy equal to 0 after a calculation 19 up to 19.6 at the upper side and 28.4 also at the upper side, we take positive, and this part act negative, the downward we take negative. 6 multiplied by 6 and 1 of 2 of 4 product by 6, this area of this triangular. After calculation it become this 19.6 plus 28.4 become 48, and after observation and calculation also this 212 and 36 become 48 and 0 to 0. So it is checked that our example is correct. Thank you for your attention.